Okay, so if we can start with Centiel's latest UPS solution, StratusPower, because I know that's already, we're talking about the sort of future, and I know that's already been designed very much with the future in mind. So yeah, just talk us through that, please.
Yeah, it's good timing we're talking about this actually. We launched it already. The product is available. We're doing a showcase with it at DCW. We've literally just commissioned our first system as far as the UK is concerned. But yeah, this product is very much focused at the future. It's sort of learning everything that we've done so far with things like Humus power, true modular architecture, and then building a layer of sustainability on top, which is everything from, I mean, sustainability is a big subject, but it's everything from, you know, how the product is manufactured, you know, how recyclable is this product, and how it's lived with over the next X amount of years, which, by the way, this product is gearing up to be lived with for let's say 30 years, as opposed to an average product life cycle like this 10, 15 at a push. So we're sort of pushing out the life cycle of this product, which makes the operational expenditure more cost effective, makes living with this system more sustainable.
Yeah, and perhaps slightly unfair to ask, because as you say, this new solution is very much got sustainability front and center. But I mean, are there sort of further things in terms of developing UPS technology that can, you know, contribute towards that sustainability, help organisations further, or with the StratusPower? Do you think this is almost as far as you can go, or so there are other things you're looking at?
That's $1 million question, isn't it? I think there's more to do. It used to be the race to success was creating a system with small footprint, high efficiency. But we've done that. Making the system the most available system you possibly can. Well, we've pretty much done that. Again, it's coming down to the components that are being used to create a longer life cycle of a product. How long are you going to live with it? But also, I think things are changing. People are actually living with their systems better. I think the future is more about how the equipment is going to be maintained. And a lot of that comes down to management of the system, management of energy, monitoring of the systems, monitoring of loads, monitoring of temperatures, environments, understanding the system that you've got and, you know, getting to know it. I know that sounds a bit cheesy, but it really isn't a system anymore where you purchase a product, it's designed for power protection, it sits in a room, you shut the door. That's sort of disappearing. We want much more connectivity, much more management, much more monitoring, and clients need to be comfortable with the system that they're purchasing. You know, we want to train them on the systems. You know, these systems are designed to be used, so let's start using them.
And in terms of just what you described, I'm imagining is AI pretty much the future in terms of adding all those should we say smart functions, the capability to monitor and manage, etc. Is that where you're headed?
Yeah, I mean AI is a stretch. I mean, we're starting to use this terminology. You know, the UPS isn't going to start, you know, thinking for itself and creating its own generations of UPSs as a community and as a race, but certainly the systems are already communicating as far as model level. They're talking to each other. They're working out what to do. They make a decision. They make an active decision whether to protect the system, isolate themselves, come back online, flag up alarms. But this is going to go further. I think in the future you'll see a little bit like your car. The system will start telling you when it needs a maintenance. It will tell you when it needs certain components replaced, like consumables, for example, capacitors and fans. So everything with the quality of components that are now being sourced compared to this thing, we're seeing a different product evolve. You know, we can't keep stretching the efficiency gains like we used to. You know, there was a big leap back in the day between, you know, a system that was 85% efficient up to 95% efficient by significant architectural differences in the systems. Now we're sort of gaining smaller increments of efficiencies. So it's all to do with, again, this living with the product and how the product behaves within your infrastructure. And I do not doubt, the more we go on, the processing unit within the system will start having better AI. And I mean, sorry, Phil,
no.
I'm going to cut you off there, but data centers, as you know, the power consumption is growing tenfold. When AI steps into the computing world, the expansion of power is going to be there anyway. So the UPS is going to have to sort of keep up. We've got power demand and we've got communication. So we're going to have to sort of keep up with that anyway. It's coming. We can't stop it.
I'm guessing as well that you as an organisation, clearly UPS is your sweet spot, but more generally around sustainability and related power issues, perhaps. So I'm just wondering whether you've got any thoughts, for example, about battery technology and fuel cells. That clearly people have been talking about what is or isn't possible for a while, but just any thoughts as either from yourself or as Centiel, what you see.
So VR relay battery blocks, they are the industry standard, and they have been for decades. They are reliable. They are completely flexible in how you can build up a system, and they are very sustainable in the fact that they are, almost like 95 more plus % recyclable. So it's a pretty good product. They are cumbersome and they only allow a certain amount of cycles. So it's not a battery you can carry on discharging and recharging. So when you flick to a different product, energy storage product, like lithium ion, for example, you can start thinking outside the box. You've got an energy storage unit that can be cycled thousands of times, and that energy is sat there. So why not use it? You see, we talk about things like peak lopping or peak shaving. So, for example, you could have your UPS running and its normal operation. You might find a peak in the price of electricity during the day. So why not draw some of that energy from the battery as well as the grid at the same time to take that peak expense off, and therefore you stabilize your energy expenses. So we're looking into doing things like this, where this isn't something, it's far in the future, this is happening now. So we want to be able to use the UPS energy storage system to benefit, the customer, and let's be really honest, we're talking about the cost of living and surviving. Also, it takes the strain off of the grid, so on and so forth. We can create a net zero usage of this particular method by recharging the batteries either in an extreme off-peak free energy time or using sustainable energy sources such as solar, wind, to create that recharge, which completely offsets that energy usage.
And I'm wondering, I know you mentioned the peak shaving, but sort of reversing the roles almost, if I got it right, the idea that data centers would potentially supply some of their power back to the grid when they're under pressure. I mean, obviously, well, I won't say everyone, but a lot of people are nervous, clearly, because data centers, mission critical. If they sort of get caught with their trousers down, if that's the right analogy, then somebody's going to get fired. But is it, theoretically, is it a possibility, do you think, that needs further exploration?
Yeah, I don't know a great deal about when a company decides to give back to the grid or they can be self-sufficient for an amount of time. I don't know when a company starts making that decision. Rather than giving energy back to the grid, I'm seeing it more and more where companies will become more self-sufficient for periods of time, alleviating the pressure off of the grid as opposed to giving it back. So, for example, you can read stories about it with your car chargers, and everyone's got their cars plugged in overnight. Well, the national grid might decide to cut the power to all those homes, discharge the batteries within the cars to power the homes, and therefore, again, alleviating the strain off the grid. So it's not necessarily sucking the energy back from the source. It's saying we're going to cut your source off for a little bit, and you're self-sufficient. And that's where I see UPS is going. I think it's more, what can that facility do locally to run self-sufficiently, so that if there were any problems with the grid, the infrastructure, they can manage it themselves rather than waiting for, you know, one of the big power companies to say you can't have your power back yet. You know, it's a little bit like Edge in a way. It's bringing the control back closer to the source, and data centers want to be in control of their energy, their pricing, their infrastructure, everything.
Good. And perhaps just widening the picture slightly, the sort of circular economy is, again, you know, another idea that's growing in importance. So that's,
Yeah.
I guess, the whole life cycle. So the ways in which you manufacture the product. And I know, again, with StratusPower, I think you looked at what happens to it, you know, at the end of life, although, as you say, it's got a potentially 30-year life. So just, again, thoughts as to how much more opportunity there is to reduce embodied carbon and or, you know, recycle or at least repurpose a UPS once it's, you know, served its purpose.
Because of the modular architecture, which most of our flagship products have, Cumulus Power, StratusPower, you're able to take modules out of service and put them in service whilst the machine is running. You're able to expand systems and decrease systems while the system is running. This allows us then to do a safe exchange program. So let's say you get to 15 years, your system needs a capacitor replacement. Well, we just come along and we put in all the modules that are required to run that system, and we take the old modules away, which will be refurbed and put into a service stock, ready for the next customer. So again, it's thinking about this. Do you really need to keep purchasing UPSs to keep them alive? Do you need to keep doing system swaps and, you know, spending a lot of capital expenditure? So then the reality of something like this, you know, your product life cycle is actually changing. I mean, it could be 40, 50 years if you do it right now. Who knows what the next 5 decades is going to look like as far as technology goes. But when we're getting efficiencies as so good as we've got, you know, the need for change is less and less. And it's then all about the enhancements that you can add in to that equipment. So, you know, there might be system upgrades that happen between now and 15 years time, that when those service exchange modules go in, they've got the latest technology. They might have an upgrade to AI. They can accept different energy sources, hydrogen fuel cell, which you're saying, linked to the smart grid, things like this. So we want to create a product that can adapt as it goes forward. You know, all the infrastructure is there. It's there to be living with the facility. You know, you're putting in switchgear and engines and air conditioning. All this equipment needs to sort of spread itself over the same service life, really. And that's sort of the aim for this type of product.
And you mentioned the Edge a little bit earlier, but just to focus on that, and this may be a silly question, if so, apologies, but clearly it's coming. I know it's been talked about and it's nearly there, and then it's nearly there, but I suspect at some stage, particularly if autonomous vehicles, etc., that we're going to have a lot more Edge facilities, whatever those look like. And I'm just wondering, does that place any different challenges on a UPS, or does it not really matter? It's just a smaller version of what might be in a, you know, larger data center, or are there different characteristics that it needs to be efficient in that environment, I guess?
So we're talking about StratusPower being all about sustainability and you know, forward thinking. It is pitched at the data center market, but that's not necessarily saying it has to be a 1.5 megawatt, a 2 megawatt, a 3 megawatt system. The same product is being developed, or is developed with the smaller modules in mind, so that it can be deployed into smaller data centers such as Edge. And as you said, you know, an Edge data center has got exactly the same components in it that a megawatt data center has got, just on a smaller scale and locally to the source. So we're able to design our systems that can fit into these smaller applications, that can integrate into other people's equipment as well, you know, things like racks and switchgear and so on and so forth, that can be sat into these localized, I don't know, maybe even greenfield areas. So we need to create a product that not only has the future in mind, but is also incredibly adaptable, scalable, can be integrated, can communicate. So we're sort of, future ready for this thing if it ever really goes off. We do see this happening. We've got several opportunities where we've put UPSs into smaller, self-contained, like almost like a data cube as such, that sits in a greenfield. It's got its own environmental control, and they sit there happily. But we've just got to be able to integrate into that system, which we can do.
And in terms of future proofing, I mean, we've talked about AI a little bit in terms of what it might do to UPSs and used, if you like, within the data center. But the world and his wife knows that there is already an AI sort of mini explosion, which apparently is going to get, well, dwarf cloud or whatever, virtualization. So again, does that place any particular, or as you said about edge, as long as you've got sort of infinitely scalable, modular, you can just scale it up to meet those demands? Or again, does it need a slightly different way of thinking to meet the potential power demands of these AI hungry language learning libraries, if I've got it right, language learning models, all the stuff that goes with them?
Phil, I mean, it's terrifying. Can we be honest about it? It's terrifying. AI is terrifying. It exists in our world already. I've used it on Google AI and created some wording and bits and bobs using it, but I'm barely scratching the surface as to its capability. I think some of the fear when it comes to systems, so the computing world, fine, AI is developing, creating and thinking. If you've got a UPS system or anything for that matter, even switchgear with devices that are controlling power, the thought of it potentially deciding for itself what to do next is a little bit scary, in the fact that could this system just decide to switch the power off? I don't know. We work very closely with companies, particularly when it comes to monitoring of UPS systems, that a lot of the communication is dial outwards only. And that stops people from dialing in to make a decision for the UPS. You think about it, anyone could maybe potentially hack a system to switch it off. So we work very closely to make sure that level of communication doesn't happen. Now, if that's fully integrated AI into UPS systems and other systems, could that be an issue? Possibly. I don't know. But we work with very sensitive customers, data centers. I'm sure you can surmise on other types of organisations that they are very strict on the communication that is given into their systems, and will only allow one channel out.
And in terms of, I mean, we covered, I think, most of the angles, but is there anything else in terms of how UPS solutions might evolve over time that you think people need to be aware of, to plan for, or I say, have we covered most of the
No, I think it's a bit of watch this space, really. We're doing as much as we can to fulfill the needs of the future at the moment. I think one of the biggest drivers is the cost of living with systems. The price of energy at the moment is tenfold. It's growing more and more. So we're just trying to do as much as we can to help customers live with their systems and be, they've got the tools there now. So let's help them get a bit smarter with their systems and manage them in a way that can ultimately save them money and ultimately help save the planet. That's what we're all trying to achieve, really.
And maybe, and this is perhaps a little bit unfair, but if we were to have this conversation in 2030, I'll pick that date because I think a lot of the data center industry has already said it's going to be net zero by then, let alone 2050, which give so they're giving themselves quite an aggressive target. I mean, would you anticipate the UPS systems of 2030 would be massively different from the StratusPower of today, or pretty much, with some things we discussed, maybe a bit more intelligent, but by and large, similar?
Unless someone is developing something I don't know about, I can't see it stepping that further in that amount of time. Having seen what I've seen for the last 5 years, 2030 is not far away. And I think the advances in this technology are steadily growing, but not at a rate that you'll see anything substantially different by that time. Beyond, 2040, when you and I are sailing away on a boat into the sunset, by then, you may start seeing differences, and we're going to start seeing, hydrogen fuel cells coming in for cars. There's going to be a technology available for these types of systems. But I think for now, I think we're really at a pinnacle on system technology.
Okay, it's been fantastic to chat and some really great insights into what is going on and what might. So, Louis, for now at least, thanks very much indeed. Thank you.
My pleasure. Thanks, Phil.